Vous voulez connaître la valeur de votre voiture simplement et rapidement en ligne sur Vendez votre voiture. Vous voulez connaître la valeur de votre voiture simplement et rapidement en ligne sur.
So in WinForms, all you have to do is double click on text.
Vous voulez connaître la valeur de votre voiture simplement et rapidement en ligne sur
Text. And what we need to do is to int, and we will assign that text. Work for and then there. Because of that, the Telegram desktop app, and we have the main. So Qt is really fast. Look it in the properties. Qt is a real feature. So that's it for this video. Hope you guys enjoyed it.
Ay.
Go Kingston.
Ay, me he inventado cosas para llamar la atención de ti. Y no solo por lo hermosa, niña, tu brillo me tiene así. Y siéntate y piensa en algo, y quiero ser ese algo. Ahí procuré seducirla mucho hasta que se dio. La acabo de hermosa y te merece todo. Amarte es mi necesidad, mi necesidad. De ti me gustan cosas, la verdad todo. Quitarte sin seguridad, mi necesidad. Es darte un par de besitos, es bailar contigo un afrito. Es decir que loquito me tiene, es decir, a que huele, huele rico al bailar. Es perfecta el despertarse. Ahí procuré seducirla mucho hasta que se dio. Ahí flaca, vos sos hermosa y te merece todo. Amarte es mi necesidad, mi necesidad. De ti me gustan cosas, la verdad todo. Quitarte sin seguridad es mi necesidad, de verdad. Ahí procuré seducirla mucho hasta que se dio. Y si supiera todo lo que yo le recé a Dios pa' que tú estuvieras aquí. Ay, mi flaca hermosa, vos otra cosa. Es el destino que nos tiene feliz. Bebé, date una idea de que flaca, vos sos hermosa y te mereces todo. Ay, amarte es mi necesidad, mi necesidad. De ti me gustan cosas, la verdad todo. Bebé, date una idea de que flaca, vos sos hermosa y te mereces todo. Ay, amarte es mi necesidad, mi necesidad. De ti me gustan cosas, la verdad todo. Yo soy tu capo, baby. Bebé. Yeah.
recibí una llamada diciéndome que estás cansada, no quieres saber de mí. Me dices que no sientes nada, no quieres estar amarrada y que yo fui el que perdí, pero no es así. Bebecita ya no me hace falta, a nuestro amor ya yo le di la espalda. Hace tiempo te lo iba a decir, bebé. En el amor yo nunca tuve suerte, por eso es que tampoco quiero verte. Al igual que tú me tengo que ir, yo tampoco te quiero, siéndote sincero. Por el orgullo pensar en mí primero, y yo tampoco te quiero, siéndote sincero. Me acostumbré a vivir la vida soltero, mejor me quedo soltero y yo de ti nada espero. Bajando puntos llegaste a cero, con tu corazón de acero. Me quedo solo y hago lo que quiero. Nada fue mi culpa, fue tu decisión y resulta que todo lo malo te gusta y a mí andar solo no me asusta. De tantas fallas me acostumbré, eres la misma que un día se fue, la que nunca me supo entender. Ahora a ti te tocó perder. De tantas fallas me acostumbré, eres la misma que un día se fue, la que nunca me supo entender. Te tocó perder. Yo tampoco te quiero, siéndote sincero. Por el orgullo pensar en mí primero, y yo tampoco te quiero, siéndote sincero. Me acostumbré a vivir la vida soltero. Era mejor que no estuviera, pa' estar contigo mejor con cualquiera. Dicen que fue mi culpa, pero si supieran, no hablarían si me conocieran. Con tu malicia piensas que me afecta, pa' tus llamadas no tengo respuesta. Contigo no pienso volver, tú jugaste y perdiste en la apuesta. Ya me cansé de ti, me olvidé. Te juro que no te llamaré, yeah, porque ya me cansé de ti, me olvidé. Al pasado ya no regresaré. Yo tampoco te quiero, siéndote sincero. Por el orgullo pensar en mí primero. Te quiero sincero. Ahora soy yo, primero, segundo y tercero. Yeah, yeah. La voz favorita, baby. Dímelo, Ciro. Yes, yeah. Yes, yeah. Yeah. Con music. Dynamic Record.
Los Vega Ton.
Shantae.
Yeah, yeah. Baby, baby, you're my sun and moon. Girl, you're everything between. A lot of pretty faces could waste my time, but you're my dream, girl. You make flowers bloom. Girl, you make the stars collide. And I don't know what I did to get lucky like this, but it sure feels fine. Cause you give me love and affection. I give you all my protection. I'm trying to stay by your side till the day I die. And you give me all of your love, and I give you all of my trust. I know you'll never betray me, you'll leave my side. Oh my baby, baby, you're my sun and moon. Girl, you're everything between. A lot of pretty faces could waste my time, but you're my dream, girl. You make flowers bloom, you make the flowers bloom. Girl, you make the stars collide. And I don't know what I did to get lucky like this, but it sure feels fine. Cause I see your face when I'm sleeping. I wake up grateful to breathe in the air you float through. I wrote you a lullaby, a song to sing on your pillow, swift as a swing on a willow. My sweetest words are mid-birds in your perfect sky. Oh my baby, baby, you're my sun and moon. Girl, you're everything between. A lot of pretty faces could waste my time, but you're my dream, girl. You make flowers bloom, you make the flowers grow, you make the stars collide. And I don't know what I did to get lucky like this, but it sure feels fine. Cause baby, baby, you're my sun and moon. Girl, you're everything between. A lot of pretty faces could waste my time, but you're my dream, girl. You make flowers grow, you make the flowers grow, you make the stars collide. And I don't know what I did to get lucky like this, but it sure feels fine. Oh my, oh my. Oh my. Oh my, oh my. Yeah. Oh my, oh my. Baby, baby, you're mine.
Ce soir pas de dodo. Ce soir pas de dodo. Dodo. Ce soir pas de dodo. Ce soir pas de dodo, je veux ton corps. Bébé, laisse-moi être l'homme, je sais comment faire. Tu sais que je sais comment faire pour faire suer nos corps. Je veux ton corps. Bébé, prendre soin de moi, tu sais comment faire. Mais ce soir pas de commentaires, yeah. Tu connais ton sort, je vais commencer tout doucement. Comme ça, tu connais tous mes mouvements, tout ça. Mais cette fois ce sera différent, crois-moi, je vais faire un peu plus violent. Des années qu'on est ensemble, mais à chaque fois qu'on se touche on doit se choquer. Je connais bien ma femme, elle aime le chocolat. Et pour la vie c'est moi son chocolat. Dodo, ce soir pas de dodo. Dodo, ce soir pas de dodo. Je veux ton corps. Je veux ton corps. Oh bébé, j'aime la façon dont tu me fais confiance. Avec moi t'as aucune méfiance. Mais cette fois t'aurais dû. Oh, je veux ton corps. Oh bébé, je veux faire ce que personne ne t'a jamais fait là. Dans chacune de mes mains je veux prendre tes cheveux. Je veux vénérer ton corps, c'est toi ma Shiva. Des années qu'on est ensemble, mais à chaque fois qu'on se touche on doit se choquer. Je connais bien ma femme, elle aime le chocolat. Et pour la vie c'est moi ton chocolat. Dodo, soir pas de dodo. Ce soir pas de dodo. Dodo. Ce soir pas de dodo.
Ahí aquí estoy yo, parqueado en el mismo lugar donde te conocí. Todo lo que suena en la radio me recuerda a una. Voy a ir acá y yo no sé si pueda, pero sigo pensando en tu boca. Me cierro en cuatro paredes, una historia tan hermosa. En estos tiempos no se ve, y yo tan loco, sigo pensando en tu baile. Mira la luna y siente que estoy al oído susurrando. Oh nana, oh nana, oh nana, oh nana, oh nana. Una historia tan hermosa, en estos tiempos no se ve. Oh nana, oh nana, oh nana, oh nana, oh nana. Mira la luna y siente que estoy al oído susurrando. La conquiste, bailando danza me la llevé, y sin prisa yo la mueve, sin tocarla la desnude. Pues yo hermosa bien lo sabe, todos los días luego sabe que me tiene loco con ese baile. Y sigo pensando en tu boca, me cierro en cuatro paredes. Una historia tan hermosa, en estos tiempos no se ve, y yo tan loco, siempre pensando en tu baile. Mira la luna y siente que estoy al oído susurrando. Oh nana, oh nana, oh nana, oh nana, oh nana. Una historia tan hermosa, en estos tiempos no se ve. Oh nana, oh nana, oh nana, oh nana, oh nana. Una historia tan hermosa, en estos tiempos no se ve.
Yo gangsta.
En estos tiempos no se ve. Una historia tan hermosa, en estos tiempos no se ve.
La conocí una tarde, con su guitarra cazaba boleros. Tenía puesto un jean y una rosita amarilla en el pelo. ¿Qué vas a hacer?, me preguntó sonriendo. Lo que tú quieras, respondí. Fuimos al mar y mojamos los sueños. Guiñé mis ojos y un delfín pintó una ola rizada en su pecho. Luego reí y rompimos el hielo. Nos mordimos los dedos, como viola en un solo de hielo. Eres como una hormiguita que me besa y me pica, que recorre mi espalda y se acuesta en mi barba. Estudiar geografía. Eres como un trapecista que atraviesa mi lengua, y tu circo de flores me carga y me suelta, perdiendo la cuenta, perdiendo la cuenta. Y tuve ganas de llorar, pero Ella hablaba de la luna y de Chopin, y yo tocaba el preludio de un beso. Luego reí y rompimos el hielo. Nos mordimos los dedos, como viola en un solo de hielo. Eres como una hormiguita que me besa y me pica, que recorre mi espalda y se acuesta en mi barba. Estudié geografía y ya eres como un trapecista que atraviesa mi lengua, y tu circo de flores me carga y me suelta, perdiendo la cuenta, perdiendo la cuenta.
Este deseo no lo puedo negar, de mirar tus labios no puedo parar, rehusando nuestro cuerpo, sudando como en el desierto, yeah. Sabemos que la gente está de más, pero si lo pides eso puede cambiar en solo un momento. Si tú quieres puedo estar adentro. Mami, es que tú me encantas, a ti yo te rezo mi santa. Nadie habla como baila, ninguna en la disco te alcanza. No, 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 es que tú me encantas, a ti yo te rezo mi santa. Nadie habla como baila, ninguna en la disco te alcanza. No, no,
Touch on my body feel like ecstasy. No other person, only you I see. My daily dose of the vitamin C. Now only you I need. Love of the bed every time that it goes down. I feel the love, why I don't need no closure. You feeling down, baby, come let me hold ya. Would you come let me hold ya? Love of the bed every time that it goes down. I feel the love, why I don't need no closure. You feeling down, baby, come let me hold ya. Would you come let me hold ya?
que tú me encantas, a ti yo te rezo mi santa. Nadie habla como baila, ninguna en la disco te alcanza. No, 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 es que tú me encantas, a ti yo te rezo mi santa. Nadie habla como baila, ninguna en la disco te alcanza. No, no, mami, toda la pena quiero curarte. Un shot de tequila con un baile, un beso en lo oscuro quiero robarte. No tengo que ver, solo sentir tu parte. No te preocupes por lo que yo gasta, yo no soy como tu último gasto. Tú pides, deja la timidez, yeah. Dame tu sonrisa, me tenía que ir, se me fue la prisa. All night long, guayando el mahón.
Oh my baby, to me like a honor. You draw me to your place. I move with your rhythm and bass. I move to your rhythm and bass. Oh my baby, to me like a honor. You draw me to your place. I move with your rhythm and bass. I move to your rhythm and bass.
Este deseo no lo puedo negar, de mirar tus labios no puedo parar, rehusando nuestro cuerpo, sudando como en el desierto, yeah. Sabemos que la gente está de más, pero si lo pides eso puede cambiar en solo un momento. Si tú quieres puedo estar adentro. Mami, es que tú me encantas, a ti yo te rezo mi santa. Nadie habla como baila, ninguna en la disco te alcanza. No, 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 es que tú me encantas, a ti yo te rezo mi santa. Nadie habla como baila, ninguna en la disco te alcanza. No, no,
Go gangsta.
Ay, me he inventado cosas para llamar la atención de ti. Y no solo por hermosa, niña, tu brillo me tiene así. Y siéntate y piensa en algo, y quiero ser ese algo. Ay, procure seducirla mucho hasta que se dé hoy. La acabo de hermosa y te merece todo. Amarte es mi necesidad, necesidad es darte un par de besitos, es bailar contigo un afrito, es decir que loquito me tiene, es decir, a que huele rico al bailar, es perfecta al despertarse. Ahí procure seducirla mucho hasta que se dio. Ahí flaca, vos sos hermosa y te mereces todo. Amarte es mi necesidad, de ti me gustan cosas, la verdad todo, quitarte esa inseguridad, es mi necesidad, de verdad. Ahí procure seducirla mucho hasta que se dio. Y si supiera todo lo que yo le recé a Dios pa' que tú estuvieras aquí. Ahí mi flaca hermosa, vos otra cosa, es el destino que nos tiene feliz. Bebé, date una idea de que flaca, vos sos hermosa y te mereces todo. Ay, amarte es mi necesidad, mi necesidad. De ti me gustan cosas, la verdad todo. Bebé, date una idea de que flaca, vos sos hermosa y te mereces todo. Ay, amarte es mi necesidad, mi necesidad. De ti me gustan cosas, la verdad todo. Yo soy tu capo, baby. Yeah. La industria pink.
Ayer recibí una llamada diciéndome que estás cansada, no quieres saber de mí. Me dices que no sientes nada, no quieres estar amarrada y que yo fui el que perdí, pero no es así. Bebecita, ya no me hace falta, a nuestro amor ya yo le di la espalda. Hace tiempo te lo iba a decir, bebé. En el amor yo nunca tuve suerte, por eso es que tampoco quiero verte. Al igual que tú me tengo que ir, yo tampoco te quiero, siéndote sincero. Por el orgullo pensar en mí primero, y yo tampoco te quiero, siéndote sincero. Me acostumbré a vivir la vida soltero, mejor me quedo soltero y yo de ti nada espero. Bajando puntos llegaste a cero, con tu corazón de acero. Me quedo solo y hago lo que quiero. Fue mi culpa, fue tu decisión y resulta que todo lo malo te gusta y a mí andar solo no me asusta. De tantas fallas me acostumbré, eres la misma que un día se fue, la que nunca me supo entender. Ahora a ti te tocó perder. De tantas fallas me acostumbré, eres la misma que un día se fue, la que nunca me supo entender. Te tocó perder. Yo tampoco te quiero, siéndote sincero. Por el orgullo pensar en mí primero, y yo tampoco te quiero, siéndote sincero. Me acostumbré a vivir la vida soltero, era mejor que no estuviera.
I was in Gaza up to last March. During my time there, we started the orphan care program.
Hey, what's up guys? My name is Eterno and welcome back to my C++ series. Today we're going to be talking about constructor member initializer lists. That's quite a sentence. Basically what it means is it's a way for us to initialize our class member functions in the constructor. So when we write a class and we add members to that class, we usually want some way of initializing those members, and that's usually done in the constructor. And there are two ways we can really initialize a class member in the constructor. Let's take a look. So I've got this entity class here which just has a name string. It doesn't have any constructors yet, so let's add one of those. Maybe a constructor that actually takes a name in as a parameter. I'll also create one more constructor that's just going to be a default constructor, and it won't. Maybe a constructor that actually takes a name in as a parameter. I'll also create one more constructor that's just going to be a default constructor, and it won't take any parameters. So in this case, I want to assign mName with value of this name that's being passed in, because I want to be able to set my entity to have the name that was passed in through this parameter. In this case, maybe I'll do something simple and just set the player's name to unknown. Now this might seem fine, and it's probably the way that you've been doing this in other languages, but in C++, there's actually one other way we could do this, and that's via remember initializer list. First of all, let's just take a look at this code and see it running and make sure it works. So I'm just going to create a new entity over here, and I'm going to print the name of that entity. I'll call this one E0 to demonstrate my first kind of case, and then another one with E1, and I'll give this one a name, such as Cherno, and we'll hit F5. You can see in this case we get unknown printing first and then Cherno. Okay, great. So everything seemed to work. Let's take a look at the second way we can initialize this. Instead of us just setting mName equal to the value over here, we can do it via remember initializer list, which looks like this. After the constructor, after you write your constructor and the parameters, we can add a colon. This can be on the same line as this, it doesn't really matter. Usually I like to write it on the next line over here, indented like this, and then you start listing off the members that you want to initialize. Now in this case we've just got mName, so all we have to do is type in the name of this variable and then give it some kind of value. So in this case, unknown. And that kind of replaces the need to do this. So this is what a member initializer list is. Now if we had another member, such as score or something like that, we would just add a comma and then the value of that member. So in this case, I'm initializing it to 0. One thing to note really quickly is that if we had defined these variables like this, in this initializer list, you should be listing off all of the members in order. And some compilers will actually warn you if you don't write the code in order. And the reason this is important is because no matter how you write your initializer list, it will be initialized in the order that the actual class members are defined in. So in this case, the integer will be initialized first and then the string, even if you write it the other way around in the initializer list, where you initialize the string first and then the integer. So this can lead to all sorts of kind of dependency problems if you break that order. So just make sure that you always initialize your variables in the same order that they're declared in when you declare them as members. In this situation, it would look like this. We have our name and then we just put in the value that we want to copy from into here like this, and that's how we assign this. It's just, you're basically replacing the equals with parentheses and moving it up into this list. If we run our code, you'll see we get the exact same result. Okay, that's it. That's member initializer lists. Really easy. The big question though is why? Why should we use this? Is it just a code style thing? And the answer is, well, yes and no. No is probably the more right answer. I like writing code like this, first of all, because if you have a lot of member variables, this can get really cluttered if you start initializing them all in here. And it might be hard to see what the constructor is actually doing, because maybe you've got some code later on that does other stuff, but most of your constructor is filled with just initializing variables. Such kind of trivial and boring tasks that you probably don't even want to, you kind of want to hide them, which is why I like to put them in the member initializer list, because just from a code style point of view, I like it more. It keeps my actual code in my constructor very, very clean and easy to read. But there is actually a functional difference, and this difference applies to classes specifically. If you write code such as this, where we assign mName to something here like unknown, and you don't have it in the member initializer list like so, what will actually happen is this mName object will be constructed twice. Once with the default constructor, and then again with this unknown parameter, because what's happening here is actually this. So you just created two strings. One of them you've just thrown away pretty much straight away, right? That's a waste of performance right there. Let's demonstrate this. I'm going to make a class here called example. It's going to be very, very simple. Just one public constructor here. We'll make this kind of more of a real world example, I guess. I'll just print created entity over here, and then I'll also create one example, which actually takes in a parameter, and I'll print created entity with, and then that X variable. I'm going to scroll down here, get rid of all this X stuff. I'm going to add this example class as an actual class member over here. I'll call it m_example to adhere to my convention. So this is it. That's the whole class. It's got two constructors, one which takes no parameters and one which takes this X. And what I really want to do is in my default constructor for entity, my constructor which takes no parameters, I just want to set example equal to an example object that actually takes in 8, right? So if I come down here and I make sure I'm actually creating this, let's get rid of this other example. We don't need to print this, and we'll get rid of the printing of getName. All I'm doing here is just creating an instance of that entity object with this default constructor. If I hit F5 to run my code, look at that. We created two entities, once with the default constructor, the one that takes no parameters, and once with the constructor that takes in an integer. So we've actually created two entities, right? One was created up here. It's as if we wrote this like this, right? I mean, it created an entity here. Why wouldn't it create an example up here? Just because it's in this kind of member region doesn't mean that it's not going to run this code and create it. And then we've also created a new example instance here and assigned it to the old one. So we've thrown away the old one. We've just created an example class instance, thrown that away, and just overwritten it with a new one. We've created two objects instead of just one, right? Whereas if we were to move this into the initializer list, there's two options for us here. We could either write exactly the same code as we did before, like this. And if I hit F5, you'll see, of course, we just run the constructor that we want. We create one entity instance, or I could even just get rid of this and just pass in the parameters like this and just hit F5. And you can see that does exactly the same thing. So there you go. That's the difference, right? You should be using member initializer lists everywhere, right? There's absolutely no reason not to use them. If you don't like the code style, get used to them, because it's not just a matter of style. There's actually a functional difference. You'll be literally wasting performance if you're not using them. Of course, not in all cases. In the case of primitive types like integers, it won't be initializing them until you initialize them yourself by assigning it, but I use it everywhere. I don't discriminate.
choix et profitez des meilleurs restaurants près de chez vous, comme Domino's Pizza.
Hey, what's up guys, my name is Sean and welcome back to my C++ series. So today we're going to be talking all about unions in C++. So a union is a little bit like a class type or a struct type, except it can only occupy the memory of like plus. Hey, what's up guys, my name is Sean and welcome back to my C++ series. So today we're going to be talking all about unions in C++. So a union is a little bit like a class type, like a struct type, except it can only occupy the memory of like one member at a time. What that means is that typically Hey, what's up guys, my name is Sean and welcome back to my C++ series. So today we're going to be talking all about unions in C++. So a union is a little bit like a class type, like a struct type, except it can only occupy the memory of like one member at a time. What that means... Hey, what's up guys? Guys, my name is Sean and welcome back to my C++ series. So today we're going to be talking all about unions in C++. So a union is a little bit like a class type, like a struct type, except it can only occupy the memory of like one member at a time. What that means is that typically if we have a struct and we declare, let's just say 4 floats or something in it, that means that we can have 4 times 4 bytes, which is a total of 16 bytes in that struct. That's how much space it occupies, because we have 4 members, and obviously as you keep adding more members to a class or a struct, the size keeps growing. A union can only have 1 member. So if I was to declare 4 floats like A, B, C, D, the size of the union would still be 4 bytes. And when I tried to address either A, like if I tried to change the value of A or B or C or D, they would literally be the same memory. So if I change A and set it to 5, the value of D would also be 5. That's how unions work. And you can use them exactly like you can use structs or classes, like you can add like static functions to them and just normal functions and methods to them and all of that stuff. However, you can't like have virtual methods, and there are some other restrictions. But usually what people use unions for is very kind of closely linked to type punning, which is what we did in the last video. So if you haven't checked that out, definitely check that out right now. But it's really useful for when you want to basically be able to either give 2 different names to the same variable. Like for example, if I had like a mathematical vector class XYZ of vec3, I might also want to address it as if it was a color RGB, right? XYZ, RGB. How can I get it so that I can use it both ways, and basically, you know, X will align with R and G will align with Y and all that kind of stuff. That's all achievable through the use of a union. So we'll take a look at some examples here. Usually I would say that unions are used anonymously, which means you don't give them a name and you definitely don't have like methods or anything in them, even though they can have that if they're not anonymous. But overall unions are really, really useful, and we'll just take a look at a few examples to see how we can use them. So I've got some code already written out here, but we'll get to that in a minute. If we just take a look at a basic example of a union, let's just say that I'm going to write an anonymous union here. We write it the same way as we kind of do with a struct, like an anonymous struct, but it's called a union. And then I can give it 2 different variables. Let's just say I'll give it float A and then int B. So what this means is that if this was a struct, we just have 2 different members. However, what we have here instead is 2 different ways to address the same memory, which means that if I was to say put this into like a struct called, I don't know, union, this might confuse things, hopefully not, and do something like this. If I was to make an instance of this union class and then set u.a to 2.0f or something like that, if I go ahead and print the value of u.a and u.b like this, F5, then you can see that what we get here is 2 and then 107 blah blah blah, because this value is the byte representation of 2 as a float, if that makes sense. So it's as if we took that memory that made up the float and then just interpreted it as it was an int. So we've type punted basically. So that's what you can use unions for, and that's what they are commonly used for. It's just a way of type punting. If I was to try and convert it into 2 different variable types or something like that, I could easily do that. So let's take a look at a more useful example. What I've got up here is essentially a vector2 and a vector4. Now, I've also got a function called print vector2, which takes in a vector2 and prints it. Now, at the moment, I can't print a vector4. However, you can see that a vector4 is really just 2 vector2s, or at least that might be one way to look at it. I mean, it's got 4 floats, this has 2 floats. Why can't we just see this vector4 as 2 vector2s? Well, what we could do if we wanted to, again, get the vector2 out of this thing, is we could do something like, you know, get, I don't know, we'll call the first part A and then the second part B. So the vector2 A would be X and Y and B would be Z and W. We could do something like this where we construct a whole like vector2 or something like that and then give it some members and return that whole thing. And we could do something like that. However, that's going to create a whole new object and we don't really want to do that. We could also type on our way into this by not having to copy anything. We still will need to copy something because we're creating a whole new type. But what we could do instead is just return a reference to a vector, which is really just a type punt version of X. So the way that we would do that is we would cast the memory address of X to a vector2 like that. and then dereference it. So you get this, right? And that could be one way of doing that. But another way of doing that is by using a union, and that will probably look a lot better as well. So to do that, I'm just going to get rid of this function and then wrap this in a union. So a union, as we know, and I'll just get rid of the name because it's going to be an anonymous union. A union, as you know, can only have one member. So we can't just leave the float x, y, z, w like this, because that would mean that x, y, z, and w would both occupy that same 4-byte space. What we need to do is actually wrap this in an anonymous struct like this. So I'll just say struct, and then put that float x, y, z, w in there like that. So now this struct is the one kind of member that the union has, which happens to be like a 16-byte structure. Now at this point, nothing's changed, right? If I go ahead and let's actually create a vector 2, or rather I'll create a vector 4, I'll just call it vector, and I'll set it equal to 1, 2, 3, 4. I can still access vector.x and whatever like normal, right? I can set this to like 2 or whatever. I can still access it as usual because like I haven't given this a name or anything like that. If I start doing that, it's going to ruin everything. But if it's an anonymous thing, it's just really just a way to kind of structure the data. It's not really adding anything. But again, the benefit here is that it's converting all of this into a single member, which is what the union expects. And finally, I'll make another struct here. So obviously this is adding a second member to the union, which means that it's going to occupy the same space as this first member. And that's going to consist of 2 vector 2s, A and B, just like that. Okay? So now I have a few ways of accessing this data inside vector 4. I can either use x, y, z, w, or I can use A and B. And A will be the same memory as x and y, and B will be the same memory as z and w. So let's check out how that can work. So I've got 1, 2, 3, 4 written down here. What I'll do is I'll print vector 2, and I'll print vector.a, okay? Just to get that result out. And then I'll set vector dot, well, I don't know, let's just say vector.z, I'll set equal to 500, and then I'll print vector 2, but this time I'll print vector.b. In fact, probably might be useful to print both of them both times, just for fun. Okay? And I'll also add a little bit of a divider, I guess, so that it's clear when we actually modified the data inside our vector. So let's take a look at this. Okay, so check that out. We have 1, 2, 3, 4 as we would expect the first time, and then 1, 2, 500, 4. So I haven't even touched the actual b part of that vector, obviously. I haven't set b.x to 500. I've set vector.z to 500, which is actually this variable here. But this variable here corresponds to b.x because it's occupying the same memory. Okay, so hopefully that's a pretty good example of how unions work. Again, they're really useful for when you want to do stuff like this, when you have multiple, or when you want multiple ways.
Peu importe votre parcours, avec Bruxelles Formation, formez-vous pour vous envoler vers le job qui vous convient.
Une vie active, pas de temps pour la sensibilité. Soulagement instantané avec Elmex Sensitif Professionnel, dispositif médical.
Hi guys, welcome back. It's Professor Hank. In this video, I'm going to show you how to use unions in your C++ programs. I'm going to show you how to create them. I'm going to show you how to define variables that are unions. I'm going to show you how to assign values to them. We're going to talk a little bit about what the theory is behind unions, what the pros are, what the cons are, and so on. And I'll write you a program in Visual Studio Community that gives you an example of all of this stuff. Okay, so let's dig into it. So what's a union? A union is like a struct that uses less memory. All right, and so you're thinking to yourself, right, what's a struct? Well, if that's you, I'm going to leave a link in the description below to a video I have going through structs in C++. For everybody else, it's like a struct, okay? So it uses less memory. What do I mean by that? Okay, so consider that you have a struct of, I don't know, an integer in a character field, right? So it contains an integer and a character in your struct. That would take up 5 bytes of memory, 1 for the character, 4 for the integer, all right? But with a union, you're not going to have that. Both the character and the integer are going to share the same memory location. In other words, you're going to share the same 4 bytes, all right? So the advantage is less memory. Now, what's the disadvantage? There's always pros and cons with everything, right? The disadvantage is you can only use one of those at a time, or you can only use a union to store one of those things at a time. So it's either going to store the character or it's going to store an integer. You can't do both, all right? So you need to optimize your memory usage. A union might be what you need, might be your solution. You often see unions, I've seen unions being used in systems programming a lot to conserve on resources, right? Because when you're creating an operating system and you want to be as tight as possible, especially on embedded systems and things, this is a way that you can save some memory. All right, so let's go ahead and take a look at what this looks like. Program that will write for you will just create a struct that just has an integer and a character, or excuse me, a union that has an integer and a character in it. So to do this, what we're going to do is we're going to use the keyword union. Okay, so we'll say union, and then you have a tag, you have a name for it. So we'll say foo. Okay, and then we'll go ahead and put a character in there, and we'll put an integer in there. Okay, now that we have a definition for what a foo is, we've created a foo. Now let's define a variable of type foo. Okay, so now with our foo, we can assign to it a character or an integer. So we can do something like this. We can say f.c equals j, say, okay? And then if I c out f.c, Okay, and then I build that and run it for you. Okay, you're going to see in the output, guess what? You're going to see J. Okay, so there it is. Now, I can also, or I can alternatively, store in the foo variable, that f variable, I can store an integer. Okay, so let's say 99, right? So if I was to say, see out f dot I, what are you going to see? You're now going to see the 99. Okay, but here's the thing, so you can see it. Here's the thing, the bits that represent the J, they've been wiped out. They've been overwritten by all of the bits that represent the 99. Okay, so what do I mean by that? Well, let me try to explain to you, okay? So when you create a variable of type foo, okay, how many bytes are there? Well, I said at the beginning that we were going to have 4 total because both fields, both variables there, the C and the I, they share the same 4 bytes. Okay, so if I do C out size of F, okay, there's 4 bytes. Okay, because the integer is 4 bytes, you get the number of bytes, that's the biggest member of the union. Okay, so of those 4 bytes, all right, when that gets created, F is going to have 4 bytes. Okay, now when we assigned to it J, that J occupied the first byte. What's in the rest of the bytes? I don't know. Right? Garbage, whatever just happened to be in that memory location when we assigned J to the union. Okay. Now, if I see out f.c, I get J, right? Because it retrieves the data in that first byte. But then as soon as I assign 99 to f.i, the J gets overwritten. We need all 4 bytes now to represent the 99. Okay. So that bit pattern that makes it the J is gone. Okay. It's the bits from the binary representation of 99 for the first byte that are now occupying that first byte. So when you see C out F of I, you see the 99 because all 4 bytes are being used to represent the 99. Now, what would happen if I were to C out F.C? Right, now remember, I told you the J is gone. So what are we going to see instead? We're going to see whatever ASCII is represented by the bit pattern of that first byte, right? So 99, there's a bit pattern in binary that represents the 99, and that requires all 4 bytes. The first byte, which was C, which contained J, got overwritten by all the bits, or those part of the bits that make up the first byte of 99. Okay, so that's why you see C there. Now let me use a different number because C, or maybe I'll just change this variable name here, right, to D, right? Because you look at that and you're like, oh my gosh, it's just printing out the name of the variable. No, that's not what's happening. Okay, so we'll change all of this to D just to prove that it's not just the name of the variable itself. Okay, so you're going to see that it's still going to show you the C because that's the bit pattern in that first byte that's there after we assign 99 to our